So what are the different types of variables that you can use? A short version here would be just four variables um, that are int, double, boolean, and string. What int represents is a whole number. A double represents decimal numbers, and boolean has just two values, which are true or false. And string is where you store texts like hello world that we used before. Now this is the short version, but let me go into a more detail on this. So as I have mentioned, Java is an objective oriented programming language. And although Java is object oriented, not all types are objects. It's built on top of a basic variable called primitives. So we're going to talk about primitive types and also something called reference types. And now what you have to remember here is primitive. What you only need to remember right now is that primitive types are for something that's more simple, and reference types are for something more complex. Primitive, so basic example of primitive types will be these three things that are above here: int, boolean, double. They just store numbers, or like true and false. That's it. A complex reference type would be you're gonna have a type of a a drink. You know, the type would be drink, and the value could be water, could be alcohol, could be Coke. You can have a reference type of, say, utensils. You can have knives, you can have spoons, you can have forks. So those are more complex than just having a number or true and false. So, but let's just talk about primitive types first here. Um, there are in total eight primitive types, and the first four are byte, short, int, and long, and they all are used to represent whole numbers. The reason why we have these four different primitive types that represents the same thing is because of this size difference. So byte uses only 1 byte, short uses 2 bytes, int uses 4, and long uses 8. So as byte would be storing a total of 2 to the eighth number of numbers, which are 256 numbers. So in byte, you can represent numbers from 1 to 8, negative 128 to plus positive 127. And short would have more, and would can represent more, and long you can represent more things. Now, as I mentioned, you're going to be using int most of the time, so that those four are the variables that you can use to represent whole numbers. There's also primitive types that, as I mentioned above, that represent decimal numbers. So there's something called float and double. The difference between them is also the size difference. Float has 4 bytes and double has 8 bytes. Because decimal numbers should represent something more precise. People tend to use double more, and there's also the one primitive type called char. a char primitive type stores stores single characters using Unicode values. So an example could be a character A. It could also be in an exclamation mark. So these are all just one Unicode values, and these you can store them in a primitive type called char. And last but not least, you have Boolean, which stores value, just two values, which is one is true and the other is false. These are primitive types, and as we go on implementing more codes, we can see how these are being used. But for now, you can just remember these four. These, not string actually. String is a reference type, so you can just remember these three primitive types that's being used the most of the time. I'm not saying that others are not being used, it's just that these three are used more often. So let's talk about reference types. Reference types, as I mentioned, have more complex values than primitive types. An example that I want to use here are points. So if you type in point and enter, IntelliJ is smart enough to import a class called point. And if you scroll above, you have this line called import Java AWT, which has the class point. So you can use this class. You're going to type in point1 equals new point and then parentheses. So what this line means is there is a point reference type variable called point1, and you just initialized it. You can also put in here some numbers. We're going to put in 1, 1. What that means is the x-axis of this point is 1 and the y-axis of this point is 1. So as I mentioned, reference variable types are more complex than primitive types. And just with this example, this point variable has two numbers, but they're not just numbers like primitive types. This one represents x-axis value, and this one represents the y-axis value. And you can also guess that the whole thing here, the whole value here is not just two numbers, it's actually a point with two numbers representing x-axis and y-axis. So it's not just, so that's what I mean by reference types being more complex. I'm going to type in more code so that I can explain to you why this is called a reference type and why this is different from primitive types. We're also going to have another point called point2, and we're going to say this is the same as point1. What we can do here also is we can just update one of the numbers. We can update the number in x-axis or y-axis, but here we're going to update x-axis. So point1 dot x equals 2. So what you just did is you accessed the value in point1, the x-axis value in point1, and you updated it to 2. System out print line. And if you actually, let's comment this out. Sorry. Let's comment this out, and then first system out print point2. Let's see what happens. If you run this, you have point with x-axis 1 and y-axis 1. Now, what you just did here is you updated point one. You didn't update point two. You updated point one's x-axis to 2. If you run this, what happens is point two's x-axis is also updated to 2. This is a reference type, and if you do the same thing for a primitive type, let's do int x equals, say, 1, and then you have another int y, which is the same as x, and you update the x-axis, not the x-axis, but the int x is number to 2. So system out println y. If these values were not primitive types, but reference types, this y would have been updated to 2, right? If you run this, it's still 1. It's not updated to 2. So did x not become updated to 2? It has been updated to 2. It's just that y has kept its value as 1. So what's the difference between these two? Let's talk about reference types first. So what's going on in the background is point 1 is pointing to a value of 0.11. Sorry, 0.1 is pointing to 0.11. So these values, these variables here are not they don't save a value. They save a reference to the value. So what that means is 0.1 is it saves a place where 0.11 is saved. So that's what I mean by this pointing to means. So when this line 24 was declared, point 2 is also pointing to 0.11. And if you update x to be 2 for 0.1, this whole thing gets updated. So 0.1 is pointing to a place, say the place is called 22. Sorry, let's just say the place is called 10. So point has a value called 10. Point 2 also has a value called 10. And what 10 represents is a place within the memory. And within that memory called 10, it holds a value of 0.21. So that's what reference types are. And that's why updating 0.1 also updates 0.2. The primitive types work differently. Primitive types, x, it's not pointing to anything. It has a value. It holds a value of 1. Line 31, y holds a value of 1. It looks at the value that x holds, and then it updates its value to be 1. Now, line 32, what it does is it just updates this value. So x holds 2 now. And if you print out y, obviously, because y has never been updated, it's going to just print out y. It's just going to print out 1. That's the difference between reference types and primitive types. The reason why reference types are called reference types, it holds a value of a reference of the value, not the value itself. Lastly, let's just talk about strings. And I mentioned strings are reference types, but let's do the same thing for strings. Let's say string let's say string1 is high, and string2 is string1. But we're going to update string1 to by. Now, because this is a reference type, you might be thinking, hey, if I print out string2, it's going to print out the updated value of by. Would it? No, it's still going to be high. So why do you call this a reference type? Strings also save the place of the value, the reference of the value. So I'll draw this out again. So string1 is pointing to high. And on line 38, what that does is it also makes string2 to point to high. But when line 39 happens, it's not like this. It's not how other reference types updates its values. When line 39 happens is string1 updates its reference and points to the value by and gets rid of that reference. So now string1 is pointing to by and string2 is pointing to high. So when you system out print ln string2, it's going to print out high instead of by. So even though string is a reference type, it acts a bit differently than other reference types.